Good evening, everyone. I'm Riddhi Jain from Atal Innovation Mission, and I warmly welcome all our young innovators tuning into this Knowledge Hub session. This is the season 4 and first episode. For this session, we are thrilled to begin with an exciting session titled Smart Tinkering with Tinker Blocks. And for this, we are honored to have with us Sri Kiran Kumar, an award-winning innovation leader with 29 years of experience, known for shaping at ATL Thinkerpreneur, mentoring young change makers, and driving technology-led innovation systems across India. And yes, he happens to be one of our regional mentors of changes as well. He will be guiding us today on how to transform ideas into working prototypes within minutes. And unmissable opportunity for everyone who is trying to be a budding innovator. And so, yeah, let's dive right in and make this an inspiring start to season 4. Over to you, sir.
Yeah, thank you, Riddhi. Thank you, and good evening, everyone. I'm very excited to share with you about something very interesting. We call it as Tinker Blocks. It's basically a rapid prototyping toolkit that you folks as students can build it yourself. This is applicable for both ATL and non-ATL students. But if you have some basic tinkering experience, that will really help you take this forward. Okay, this is the first of the 3-part series in this Tinker Block series of sessions. In the first session, I'm going to give you a broad overview of what Tinker Blocks are. And in the second session, I'm going to talk more in detail about how can we build the Tinker Blocks, how can we rapidly build prototypes. In just minutes, you can have your projects ready and working. And in the third session, I'm going to talk in more detail about how you can accelerate your tinkering and innovation projects. All right. So I hope all of you are excited. Let's begin. So I'm sure all of you have been going to your ATLs, visiting your ATLs regularly. You're tinkering, innovating, and building lots of projects. And maybe you're showcasing some of them in your schools, in the school innovation marathon, or somewhere else in some of the competitions. But how has been your experience tinkering in the ATL? Is it easy? Is it hard? Do you get sufficient time to tinker in your ATL? Because I understand that many of you also have classes, right? Maybe sometimes you have to skip classes if you have to go to the ATL. There are quite a few challenges. Maybe you get an hour or two in a week to visit the ATL, and you have to make the most out of that time, whatever limited time you get in the ATL. And also, if you look at what it takes to start tinkering, let's say as a beginner, did you have to go through some struggles in tinkering, building your projects? Did you have a steep learning curve in terms of understanding those electronic devices like the sensors and actuators, Arduino programming, or whatever, any prototype that you wanted to build? Did you have to go through a lot of challenges? Maybe you needed a mentor to guide you or a teacher to guide you. And you had to go through a lot of patience and you had to have a lot of perseverance to make something work, right? So these are some of the typical challenges I'm sure many of you would be facing, isn't it? So I'm sure some of you already recognize these kind of devices that you might find in your ATL. Can you name some of these? Maybe you can type it in your chat window on YouTube. Let's identify how many of them you can recognize here. Okay, if you're regular to the ATL, you'll know some of these devices and you might be building projects with these. Okay, all right. So here is a motion sensor over here, soil moisture sensor, raindrop sensor, a DC motor, for example, a temperature sensor, ultrasonic sensor, fire sensor, buzzer, you name it. There are lots of these sensors and actuator devices. What are sensors? Sensors actually sense data from a surrounding environment and gives it to a computer or some kind of device to process it further. Whereas actuator takes an electrical signal and does some action, whether it is turning a motor or pumping water or buzzing or doing something else. So there are lots of things that you could do with sensors and actuators. And I'm sure many of you have used these. And at the same time, you must have used these kind of devices as well. What are these? Can you recognize them? What is this? I think the name is written on some of them, at least one of them on the left. Yes, of course, it's the Arduino Uno, and the one on the right side is the Node MCU. I'm sure most of the students in ATLs would have used Arduino Uno for their programming and connecting sensors and actuator-based projects. And Node MCU is also something similar. It also has a Wi-Fi built in. You can do Arduino programming even with this kind of microcontroller. And the thing about these two devices is you can program it, you can connect sensors and actuators, and you can build very interesting projects, right? So I'm sure you would know some of these, if not everything. And now let me ask you this question. Let's say you wanted to build a circuit using these kind of devices, some sensors and actuators and Arduino device and all that. Let's say you want to build a fire detection and suppression system, something like it can detect fire and it can process it. It can understand that there is a fire maybe in your house, a kitchen or somewhere, and it can automatically turn on a water pump or a buzzer to alert the users. If it is a water pump, it can spray water and douse the fire, right? So if you want to build something like this, this is a circuit diagram for it. But what does it take for you to build the circuit diagram? Let's say when you are still at the tinkering stage, very beginner as an ATL student, how much time would it take for you to build something like this? There are a lot of things here. It's not just connecting the wires and building the circuit using some breadboard, but also understanding how these devices work. What are the pins? What are the configurations? Where to connect what? And if you don't connect it the right way, things won't work. And sometimes mistakes can also burn up your circuit, right? So there are lots of hurdles that you have to go through before something like this can work and actually you can showcase it successfully. And it requires a lot of patience and perseverance if you had to make this work, right? So this is what are some of the key challenges I see with ATL students. So if I were to summarize some of these things, I would say limited time. Like many of you in the ATL have very limited time to tinker during school hours, isn't it? And lack of knowledge and skills, especially if you are just a beginner tinkerer, you will struggle with these kind of skills. You would definitely need handholding from your students, senior students or teachers or mentors. And steep learning curve, right? Learning new technology is not so easy, especially electronic sensors, actuators, microcontroller. It takes quite a bit of effort. And only if you continue to work on it further, you will be able to build something, something that works, a working prototype that you can showcase as well. And if you actually see the building blocks that we have pretty much remained the same. We have the Arduino Uno, we have a few variants of Arduino, we have the Node MCUs, we have sensors and actuators, but you still have to use the wires, jumper wires and breadboards and things like that to connect them. It takes quite some time to make things work and all that. And so you are pretty much as a beginner tinkerer, you would still be dependent on the ATL in charges or mentors, right? Otherwise, you may get stuck and you may not be able to make progress unless you've been at it and you have gone through the struggle and you have understood things. And now some of you may be capable of doing it on your own. And at the same time, I also see that many students are reinventing the wheel. That means for every project that your tinkering project or innovation project you do, you still rebuild the circuits again and again. It's a waste of time, I feel. You shouldn't be reinventing the wheel. Rather, if you can take your first project and reuse it in your second project rather than throwing it away, it can actually save time for you, isn't it? So we are going to do something similar, but we are going to package it better so that it becomes a lot more value adding to you so that you can tinker and innovate faster, better, and you will have more fun. And you can go from your idea to prototype, a working prototype in just a matter of minutes rather than in days, weeks, or months. That's what the value proposition of today's session is. And you might say, sir, we already have some ready-made tinkering toolkits that we use, like an IoT toolkit or a robotic toolkit that we have, and we can use that. Yes, I would say yes, there definitely you can use some of these toolkits, but you should also know what are the pros and cons of those toolkits, what you can do and what you cannot do with these kits. The thing is about these toolkits is they give you some components, they give you some blocks, and you can definitely assemble them as per instructions and you can make it work. But beyond that, you cannot extend them, you cannot customize them. And if you have used this kind of kits for a few days or a few times, then you are pretty much done with it because you cannot take it forward because it's pretty much boxed and it's limited. The kind of things, the number of projects you can do will be limited. Of course, this is also suitable for beginners, But if you want to take your projects and build on top of the earlier projects and innovate faster, build more complex innovations, this is not the right thing because they will also come with limitations. So we are going to look at something that is more customizable, extendable, and something which you can build on top of your previous work today. And that is something called as building your own tinkering or innovation kit. So let me show you a few blocks. Let me stop sharing my screen and let me show you what I have built, and hopefully you can also build it. Okay, so let me show you a few blocks like this. Can you see this block? It's a block. It's a cube like shaped, and if you see, there's a fan mounted on it, and if you don't see on the side, there is a motor attached to it. And this is one block. And similarly, we have more blocks. Let me show you. This has, what you see here, there is some sensor here. This is a fire sensor. This is another block that you can build, right? I'll tell you what I'm doing. And yeah, this is a buzzer. In fact, this one I showed you is a buzzer, and this is a fire sensor. So many of these sensors and actuators have been actually put inside these blocks, okay, so that they become reusable. Okay, so you build the circuit once and you can reuse it again and again. Let me show you one more block here. Yeah. So this is called as a power block. A power block is something that gives you power supply, and this is called as a processor block. Okay, so you can do multiple things with these blocks. If you see, all of them have multiple colors, different colored blocks doing different things, right? So all of these, this is what we are going to build now today, and you will have lots of fun with them. Okay, let me go back to my screen and show you a few more things, and then I'll come back and share, do some more demos. All right, so you saw what are these blocks. So these are, I call them as tinker blocks. The tinker blocks are basically a rapid prototyping toolkit. And the simple thing is we have taken each of these sensors and actuators that you saw in the earlier screen. We have just put each of those sensors and actuators in different blocks. All the sensors are in yellow block, all the actuators are in orange colored blocks. The power block is red in color, and the processor block, which has the Arduino or the Node MCU, which is in the blue block. And we just had to plug these blocks one to each other, and boom, you can just build a circuit or build a complete working prototype in just a matter of minutes. And this Tinker blocks not only has physical blocks like these, what you see on the screen here, but also has virtual blocks. Virtual blocks are basically software blocks, software building blocks. Okay, the software building blocks can be a robotic thing, it could be AI, it could be IoT, it could be augmented reality, it could be virtual reality, it could be blockchain. So if you already have some code, or if you have some software pieces, it could be a mobile app, something could be a website. If you already have some of these things, you can make them, convert them into a virtual block. And when we combine this physical block and the virtual block together, it becomes a rapid prototype. So if you have a prototype idea, you can convert your idea into a working prototype in just minutes. The key thing about this is you need to first build these blocks. Once you have a few blocks, a physical blocks and a few virtual blocks, then all it takes is to put them together, and then out comes the prototype in minutes. Of course, the first time it's going to be a little bit of effort. So I would say in your ATL, if you have about 10, 15 students, each of you take up one block, building one block, and within a week or so, you will have all your blocks ready, and then you can start prototyping very rapidly. Okay, so it hides the technological complexity. So beginner students will otherwise struggle with many of these things, right? So it puts all the circuits. So instead of building the circuit again and again for every time for your project, you build the circuit once and you put it inside these blocks, and then next time you can just reuse it. You just plug the existing block to a new project, and the new project is more or less ready very quickly without spending too much of effort. Okay, so at the basic level, we have 4 types of blocks. One is we call as a sensor block. A sensor block can contain any type of DIY sensor, whether it's a raindrop sensor, fire sensor, whether it's a motion sensor, whatever. You put whatever sensors you want. You can build multiple sensor blocks. You can also build multiple actuator blocks. You can put a DC motor or a buzzer or a water pump, anything that you want in that. It could be an LED light. Whereas the power block and the processor block have very distinct functions. The power block takes input power supply either from a battery or from an external power source, and its job is to give power to all of the blocks. So you see those holes here on the power block, you can just plug the other blocks onto these holes. Similarly, the processor block has a node MCU, which has a Wi-Fi connectivity. You can do Arduino programming to it, and you can connect one of the pins from the sensor block to one of the pins on the processor block. Okay. And the data goes from the sensor block to the processor block. Processor block has a code which runs an Arduino program, which runs and it processes. It can also send the data out to some other software. It can do all sorts of very interesting things. Think of the processor block as the brain of your project or application. So this is how the 4 types of blocks we can build. So if you want to build a project, all you have to do is take 2 or 3 blocks and just like plug one to the other, snap one block onto the other, and you just get a working prototype in just a minute. And you have to just connect 2 wires called as patch cords. And once you connect those wires, boom, your project is ready. That's all you have to do because you've already done the wiring, circuiting, everything beforehand. The blocks already have them, so you don't have to reinvent the wheel again and again. So let me show you how the block looks like. Let me stop sharing the screen again, and let me quickly show you how the blocks look on the inside. Let's take one of these blocks here. Yeah, so let me take the buzzer block. So you see the buzzer block here. What I've done is to make it easy. Yeah, put some rubber bands onto this. So you can very easily open it up and you can put it back as well. So I'm going to just open it. It's going to look like this. So if you see this, if you see on the other side, you have the buzzer here, an LED here. There's a male barrel connector here for plugging onto other blocks. Then there's a switch. There's a data pin to which you are going to connect the processor block through a wire. And then this is called as a female barrel connector to which you can connect another block to this block. Okay, this is how it works. And at the back side, there's a little bit of wiring that you have to do. Hope you're all able to see this. And all you have to do is just put this back again like this. And your block is ready. And you have to just put the rubber band. All right, so this is as simple as this. Why we keep it as a rubber band, why we don't fix it is because you want to tinker again and again. You want to make changes to your blocks. You want to improve it. You can make some changes and it comes back like this. All right. So this is how you're going to build blocks. Now let me go back to my screen sharing and hope you can see my screen again. Okay, let's go to the next slide. So the thing is, you can take multiple blocks, connect them in very different ways. You can just plug one to the other like this. You can build blocks like these, or you can build blocks like this. It's called daisy chaining. You can connect one block to the next block, to the next block, and next block. You can go in any direction, all the 4 directions. You can go up, you can go left, right, back, front, everywhere. And if you want to keep some of the blocks away, you can use something called as a power patch cord or a data patch cord. And this blue wire is called a data patch cord, black is called a power patch cord. And you can keep these blocks away also, and still they're working together. So, or you can put all of them together like this. Okay, so this is how you work. And now let's see how to build a very simple application which involves a temperature block and a buzzer block, or let's say even it could be a servo motor block. So at the minimum, you need a power block, you need a processor block, you need a temperature block, and instead of a buzzer block, what I've shown here, I'm going to put a servo motor block. Okay, so let's see how it looks when I'll stop sharing screen again, and let me show you how I have actually assembled these 4 blocks together. Okay, I've just put this on a tray so that you can actually see them. Can you see these blocks? Can you see these? I've just put it on a tray so that if you see, there is this yellow colored block, which is the temperature block, and on the other side is the servo motor block, and this is the blue block, which is the processor block, and behind that is the red block, which is actually the power block. And the red block gets power supply from an external power source. It could be from an AC to DC adapter, and these are the 2 blue wires, which are called as the patch cords, which is basically taking the data from the processor block, giving it to the actuator here, and also taking the data from the sensor feeding it to the processor block here. This is how this whole thing works. Okay. All right. So you just have to connect these blocks like this. You can stack it up vertically also or horizontally as well. Right. And let me come back to screen sharing very quickly. Yeah. So now that you have connected these blocks like this, I've just shown you how I connected the blocks, multiple blocks. You just had to plug one block to the other. But how do you visualize the data? Of course, what you normally do is you connect a Arduino IDE or a cloud editor through a data cable, and then you would open the serial monitor and see the data coming from these sensors, right? So that's the old way of doing things. It's the crude way of doing things. I would say a smart way of doing things with the Tinker blocks is you have a QR code, which is actually displayed on, which is actually stuck on the one of the Tinker blocks. So you go and just scan this QR code, and immediately on your mobile phone, you can actually see the display that coming. If you have scan the QR code on a temperature block, you will actually see the temperature reading coming on the dashboard. Just scan this QR code you see at the bottom right now. You can see live data coming from this Tinker block that I just showed you on screen. You will actually be able to see this thermometer here. You will also be able to see this gauge with a humidity reading. Okay, you will be able to see these data right live readings now. Just scan this QR code and you can instantly see the data that is coming from the blocks that are in my home right now in Bangalore. Whether you are in Delhi, whether you are in Hyderabad, Mumbai, whether you are sitting in US or Australia, it doesn't matter, but you can see the data coming from my Tinker blocks right now. Anywhere in the world, you can see the data. All right, that's the power of these Tinker blocks. Just scan the data and immediately you can see it. No hassles, no coding, nothing required, because the code has already been done once and you have to just scan it. This is one way of reading the data. Let me show you more interesting ways. The other way is, maybe some of you have experienced this virtual reality, augmented reality. You have to wear a goggles and all that, right? And you put the headset on your eyes, you can experience virtual reality, augmented reality. Augmented reality is augmenting some digital data on top of a physical object. So there is something called as a zap code here. And if you just scan this zap code, I don't know whether you can see the zap code on the block I showed earlier, but if you scan the zap code with an app called Zapper app, you can instantly, what it does is you will see the temperature and humidity reading visible on your physical block. So this is how the Tinker blocks can be integrated with augmented reality. So Tinker blocks can give you augmented reality experience as well. All right. So Tinker blocks can do many things. You can visualize on a web page. You can also visualize in augmented reality. Not just that, Tinker blocks you can be integrated with a chatbot as well. So you can interact with your chatbot to interact with your Tinker blocks through a chatbot. So if you scan this QR code right here, it will actually open up a Tinker blocks chatbot where you can chat with that chatbot and say, I want a temperature reading now. What is the temperature now? Or you could say, what is the humidity now? Or I want to control the servo motor, or I want to control the DC motor. You can ask any question to it, or it can give any command to the chatbot and it can respond to you. All right. So this is how the chatbot works. So in this case, I'm saying I want to view the temperature, and it has shown me the temperature reading in degrees Celsius. Similarly, in this chatbot example, the second one, I say, I want to rotate the servo motor clockwise. And the moment I click this button, the chatbot sends a command to the Tinker blocks, and the Tinker blocks will rotate the servo motor clockwise. Or you can also say, I want to rotate it counterclockwise. Do you really want to see how it works? I can show you right away. All right, so let me just click and open this. So this is the Tinker blocks chatbot. Okay, so I'm going to click and say view temperature. Where is this temperature coming from? From the Tinker blocks that I've just shown you a few minutes back. Okay. So it says 40.5 degrees Celsius. Of course, this is a little bit off because this is a DIY sensor. It's not really 40 degrees in Bangalore right now. It's much cooler. It has just rained. Okay, the sensor may be a little faulty, but anyway, it has got the data from the sensor. All right, so I can always go back and I can say I want to view the humidity as well. And if I click on view humidity, it is actually going to the Tinker blocks live, fetching the data from the Tinker blocks and displaying the humidity reading for you. Okay. Now, if I say I want to control the servo motor, and I can click on this, and I want to say rotate the servo motor forward. I don't know whether you can see my screen here. I'm going to show it to the camera. I'm going to click on this forward, so rotate servo motor forward, and in a few, it might take a few seconds or so, and then it should turn on the servo motor. Okay. Can you see the servo motor rotate? I don't know whether you could see it, but the servo motor rotated forward. And if I say rotate the servo motor backwards, it will again rotate the servo motor backward as well. So you will see the servo motor rotating backwards. Hope you could see it. Riddhi or Suman, were you able to see it? All right, so let's go back to the slides. So this is the power of Tinker blocks. Now Tinker blocks has much more than to offer you. So if you want to build a voice activated application, you can again have Tinker blocks responding to you in voice. You could say, you could just say in voice, what is the temperature now? And the Tinker blocks will respond to you saying the temperature reading. Similarly, you could say, I want to turn on the light in my room. It will respond by turning on the light. It can do many things like this. So this is a simple voice activated application. You want to see the demo of this? Let me show you this example as well. So hope you're able to see my screen. Okay, so this is a voice activated application. I like to click on speech, and then I'll allow it to Tinker block. What is the temperature now?
The temperature now is 40.10 degrees Celsius.
Hope you could hear it. Tinker blocks, tell me the humidity reading now.
The humidity now is 32%.
All right, hope you saw how Tinker blocks works now, right? So you could see the voice activated application as well. That's all coming live from my Tinker blocks that I just showed you earlier. Okay, so we saw this as well. And now you can also use your face. You can use artificial intelligence with Tinker blocks. You show your face to the Tinker blocks through a camera, and it can immediately trigger or activate one of the actuator blocks, which is connected to your Tinker blocks application. So that's as simple as that. So you just show your face. If it recognizes your face, then you can trigger a buzzer, for example, or you can open a door or close the door. You can build very practical applications. If an intruder is present, it may not open the door. If a known person is there, it will open the door. So if you have a actuator which opens or closes the door, you can integrate that with this. In fact, you can integrate teachable machine application also with this. Teachable machine is a very simple application which can be used for image classification or in some sense face recognition as well. And you can also integrate Tinker blocks with IoT platforms like ThinkSpeak or the Arduino Cloud and things like that. So you can visually see all the temperature readings, humidity readings, and things like that. Let me show you very quickly how the IoT platform is integrated with Tinker blocks. Can you see this? It says ThinkSpeak. ThinkSpeak is an IoT platform. And can you see this reading here? The same reading that you saw, the temperature is in degrees Celsius. This you can see it visually like this. Isn't this more interesting, more engaging, more fun to see your sensor readings and the graphs and trends, how the temperature is varying, all of these in a visual format rather than some numbers on a serial monitor on your Arduino IDE, right? This is much better, isn't it? The children, beginners, will have more fun if they can see things colorfully like this, rather than some dry numbers popping up on your serial monitor screen and like scrolling off very quickly, right? So this is the humidity reading. You can also see the fire status. Right now, the fire block is switched off, so you don't see any status. Otherwise, it will turn red if there is a fire. You can also control the buzzer, or you can also control the servo motor. So earlier I did click forward and through the chatbot, and I can also click here and it will turn the servo motor on. Or I can click rotate backward. Similarly, I can say turn on the buzzer or turn off the buzzer. So buzzer is currently not connected to the Tinker block, so you'll not see any action, but this is how it works. All right. So Riddhi, is it fine? Are things going fine so far?
Yes, sir. So, would you want to conclude it now because we are left with only 3 minutes?
3 minutes. I'm almost done. Yeah.
All
so
right,
very
all right.
quickly, I'll finish it off. So you can also create your own project dashboards like this, something like this. Okay, it's up to you how you want to build it. You can also have a virtual mentor with Tinker blocks. If you actually scan this QR code on a Power Block, it'll open Google Gemini and you can ask it any questions that you have related to the Tinker blocks or anything. Or you can open Google Notebook LM where all this data is already there. It can answer questions very specific to Tinker blocks. You have a virtual mentor as well. You can build your own Tinker blocks, whatever type of Tinker block that you want to build. You can extend the number of type of blocks you want to build, and you can have fun. You can build a robotic wheel and you can build robotic blocks, or you can build a drone with the propeller blocks. You can build a camera block, or you can create all this scrubber motors and things like these. Or you can build a variety of student projects in variety of applications: home monitoring, forest monitoring, weather monitoring, pet tracking, pollution monitoring, you name it, you can build. So Tinker blocks offers you many benefits. It hides the technological complexities, allows you to convert working prototypes to ideas to working prototypes in just a few minutes, provides higher level building blocks, and it enhances your creativity, and you can build on top of your previous work. You don't have to reinvent the wheel. So this is what I wanted to share in today's session. And session 2, I'm going to cover a few more things. This is on, I think, tentatively on 28th of November. So if you are interested in knowing how to actually build these Tinker blocks, I'm going to explain in detail the steps involved in building these. So, and also I'll show you how to build a fire alarm application, how you can rapidly prototype it using Tinker blocks. And I'm going to show you a few more things. So if you are interested in knowing more about Tinker blocks, you want to build your own Tinker blocks, so make sure to attend the second session. All right. So thank you for your time. And this is what I wanted to cover today. Over to you, Riddhi.
Thank you so much, sir. And it was such an insightful and I'll say fascinating start to our series. And I'll call it smart tinkering, what you have covered today. And it was this was the first of the 3 series that sir is going to cover. And we'll continue exploring this powerful concept of smart tinkering along with the real world applications and how we can actually build it. That's a mention. And we'll be covering the sessions on 28th November and 5th December subsequently. So understanding smart tinkering is essential for rapid project building, as sir mentioned, and we look forward to seeing all of you in the upcoming sessions. Thank you so much, everyone. Thank you, sir, for your time.
Thank you, Riddhi. Thank you so much for the opportunity.